in the year December 2016, and he's also awarded with the best research paper in the International Symposium on Signal Processing and Intelligent Recognition Systems. His research publications include 10 reputed journals and 23 international conferences. He has also guided 2 doctoral and 4 master's students. Then his areas of interest includes signal processing, machine learning, and artificial intelligence. So, on behalf of each and everyone present here, I invite you, sir, for the section. Sir, please.
Thank you so much, sir, for introducing me. Basically, I think all of you can hear me, right?
Yes, sir, it is audible, sir.
Okay. Yeah. So thank you so much for inviting me. So actually I have a long-standing relationship with Vishwajyoti. So whenever somebody is calling, I don't miss that opportunity because of my few of my friends are working there. Anishin is one of my best friends. So he also did his MTech from Amrita. Okay, so and also he's from my place, just a few minutes from my home. Because of that, actually I don't miss any opportunity. And once again, I thank you all for considering me for these workshops. Okay, so before I start, sir, can you just help me in sharing my PPT? I saw this option, but I just
you are the co-host, so you can have the option to share. So no problem.
No, actually, in my slide there are some audio files also. I would like to play that, but will it be audible to you? I'm not very sure because there is an option to share the computer audio also. I can't see that. So
you also have no idea on that.
Oh my God. Okay. All right. Let me just take 1 or 2 minutes to just check.
Okay, no problem.
If anybody in participants would be knowing about this,
participant any idea about how to share the video with volume?
Because my slide has a lot of. Let me check actually. Yes, I got it. Yes,
okay.
I got it. Yes. Okay, all of you can see my screen?
Yes, sir. Yes, sir. It is.
All right. Yes. Right. So can I check the audio?
No problem. So check.
I'll just check.
Author of The Danger Trail, Philip Steele.
So can you hear this? Can you hear this audio when I play this?
Author of The Danger Trail, Philip Steele.
Yeah, it is okay.
It's okay. So all of you can hear properly?
Yes, sir. It's audible.
Okay. Yeah. Now I'll just check one video also. I have few videos. Okay. Okay. Just
blank screen, sir.
A blank screen. Okay. I think my codec is out of, outdated maybe. Okay. Just it's okay. It's not important. Maybe I'll just proceed with this. Okay.
Can you enlarge the screen, sir?
Oh,
fine,
okay.
fine.
Is that okay? Yeah. Thank you so much for giving this opportunity to speak in the context of speak about the speech recognition in the context of robotics and IoT applications. Okay, as you all know that these days the technologies like data science, artificial intelligence, machine learnings are actually booming up. All the jobs and also whole market is actually driven by these technologies. And among these technologies like this IoT, whether it is IoT, robotics, data science, or artificial intelligence, among all these technologies, this speech recognition is one of the buzzwords. Also, there are other buzzwords as well. So whenever somebody is actually seeing a word like automatic, for example, a student in his or her resume, if you're actually putting speech recognition, so that resume will have some kind of weight, because it is one of the important topics which are actually discussed in the context of AI, data science, and this one, robotics, etc. All right. So this particular topic has its own importance. So in the context, basically, so I'm not a mechanical engineer. So I will just I would like to share my own experience in the context of using or developing a speech recognition system for a robotics company. So that is why I was actually I told Shanmugesh sir to keep this one. There is no harm in keeping automatic speech recognition, because there are a lot of people are actually working on incorporating this speech recognition modules in various applications related to the robotics. So I'll just share, I'll just take out this one for some time. I'll just take my browser. Okay, so I'll just show you some of the applications. So see, nowadays, all of us are actually, purchasing, all of us are actually doing the online purchase, especially during this lockdown or COVID times. Okay, so the number of purchases, online purchases, have been increased drastically. Okay, so when you are actually placing an order, for example, all of you are actually familiar with using Amazon or Flipkart, okay, to purchase some phone, laptops, or any other item. So do you think that these products, whatever you're actually the placing, or when you place a purchase order to purchase something, so do you think that all these Amazon or Flipkart will have their own warehouses where they are keeping all these products? No, it is not. Okay, basically they are actually outsourcing their products to they have their own, they don't have their own warehouses. They are actually giving to companies who are managing these warehouses. Okay, so I'm just showing a kind of a warehouse of a particular company called Adverb Technologies Limited, because so I've been consulting with this particular company. This particular company is actually a company which manages warehouse activities, because when you place an order in Amazon, so what it is actually doing is that it is going to give a particular company which has a kind of warehouse where all these products will be kept. Okay, and these companies' job is actually to manage efficiently the warehouses. So they will have their own robots. You can see some of the robots here. Okay, so I'll show you how exactly this is happening. So I think all of you can see this video, right? So can you see this? Hello?
What, sir?
So can you see this video?
No, sir.
No.
Still, we are seeing your first slide only.
My God. 1 minute. I think I just shared my. I'll do one thing. I'll just share. I'll just stop my
Just
sharing.
share your
I'll
entire
just share.
screen.
Yeah. That I will do it. Now you can see. This is the slide. Now I am in my slide. Now.
Yes, sir. Yes, sir. Our products.
So can you see this?
Yes, sir. Yes, sir. Yes, sir.
Oh, video also you can see, along
Very
with the
good.
audio, right?
Very good.
All right. Okay. All right. Have you seen that?
Yes, sir. It's clear, sir.
Okay. So the basic idea here is that you can see one person actually, having his headphone mounted. Okay, he's speaking something through the headphone. Actually, he's giving instructions, keywords of number of products to be picked from this a place in a particular shelf or rack. Okay, he's actually telling this the name of the product. For example, if he needs to pick around 10 sachets of shampoos, he'll be telling through his headphone that 10 sachets of shampoo. The instruction is actually, the speech is going to that particular robot. Okay, a robot kind of thing, one kind of gadget. Okay, you have seen, no? So some gadget is actually going through a tray and it is actually putting something. So you've seen that, right? So that instruction is actually given by one human operator. Okay, and what the robot is actually doing is that it is going to take that particular speech, collect the speech. It is going to convert that speech into text. Okay, and it will understand the keywords, like the number of the numbers, especially numbers, and the keywords, pick 10 sachets. So these are the two keywords. So by understanding that keywords, it is going to go to that particular shelf, which where going to that particular shelf is actually pre-programmed in the robot actually. So only robot was actually waiting for that particular keywords. Okay, so which will be converted to text and it will be processed by the robot. So this is one of the booming areas, the warehouse management, where people are actually, so it is not this company. So this company, why I showed you, because that particular speech recognition system, the automatic pick speech recognition module, is actually developed by us, because that is actually, they named it as Cushy. It was actually one of my consultancy work which I carried out last year. Okay, especially during this, recently only it launched actually, especially the major work was done during the lockdown. Okay, so that was so that is actually the application, the one of the potential application of the speech recognition in robotics. And also this warehouse, this particular company is a warehouse management company. Similarly, there are many companies companies which uses Honeywell is one of their close competitors. All these warehouse management companies are actually into this using the AI technologies for efficiently managing their, or optimally managing their warehouse operations. Okay, so it's not so easy to develop a speech recognition system, because you can see that the warehouse has a lot of noise there. Okay, I'll come to that. What are the challenges in the development of speech recognition system? Okay, so hope it is clear to you. I just wanted to relate how speech recognition is quite closely aligned with robotics and IoT, which is actually the theme of this particular FDP. Okay, hope it's clear. Is that okay? Shall I proceed with the speech recognition application?
No problem. Continue, sir.
Yeah. So maybe if you have any question, you can actually interrupt me. You can stop me anytime you want. We shall discuss. Okay. All right. I'll just proceed with the topic. So basically, speech. I'll just whenever I used to give talk in speech processing, I'll just start with the speech signal. So what is the speciality of speech signal? Okay, so it has got a lot of information contained in it. For example, if I have recorded a particular 3-second duration, a 3-second long audio clip that I'm going to Bombay. Okay, so that is actually the recorded clip. So what are the information present in that? Okay, so first information which is there is the message. Okay, the message. So what is the message there? I'm going to Bombay. So message is one important information. The second one is actually the speaker information. So speaker, who is speaking? The speaker information is one of the important information. Speaker information is there. Then what are the other important information present? Accent or language. So language. So I'm going to Bombay. It is spoken in English. Okay, so what is a language of communication? So that is actually embedded in speech. Okay, then accent. So I'm basically a Malayali. So even if I'm speaking English, my mother tongue influence will be there. So that accent information is also there in in the speech. Then a speaker I already told. Then there will be some other the paralinguistic information, like nothing related to the language. That is also there. For example, emotions or stress. So if I'm actually completely stressed up, or if I'm tired, if I'm feeling sleepy, if I talk, all those information will be affecting our the way in which we are actually communicating, way in which we are speaking. Okay, so these informations are actually present. So I can say that a speech signal is a kind of it is abundant with information. Okay, the information content is much more as compared to any other signals. Okay, so that is actually so people have developed different applications considering the potential, the abundance of this information. For example, certain application, if somebody is actually interested in knowing or extracting the message part, then that particular application is actually known as speech recognition. So speech recognition, so I'm not interested in any other information like language, accent, speaker. So language will come if you just consider the speech recognition. So if I'm not interested in other information such as speaker accent or emotions, etc., so I can just throw away the other information. I can just focus on extracting the message part. That is actually the objective of speech recognition. Okay, then you have the emotion. For example, if you have another important application is that personal development of person authentication system. For example, I am not interested in the message, but I am interested in who is the speaker. So for example, so all of you in all the organization, including our organization, so whenever we are actually coming, not now, now we are actually sitting in the lockdown period, we are sitting at home and taking. But when we go to college, actually there is a rule that before 8:45, before 9 o'clock, you have to punch. Okay, so what is that system? Actually, it's a biometric person authentication system. So you're keeping your finger there in the punching system, and attendance will be marked. Okay, so basically say a kind of person authentication system. If you are actually you can extract the speaker information from the speech, then you can actually go for developing a speaker recognition system. So I'm not interested in any other information present in the speech, but I'm actually interested in speaker only. Okay, so but it is not a simple recognition system, but it has to be verified. For example, I'm going to tell the system that, okay, my name is Govind. Okay, so the system has to compare the model, the Govind model which is already there, and whatever the data which is given to the system now. So there will be a match. So whenever there is a the match is actually the similarities going a particular above a particular point, then that particular speech, that particular person will be authenticated, the access will be granted, or the access will be denied. Okay, so that is how as speaker verification system works. So it is recognition is also a similar thing, but there is no, in the case of a recognition system, it is a closed one. Okay, so there is no verification happening there. So even if a person from outside is actually accessing the system, he can access. So he'll be assigned to one of the model which is to which they are actually closer. Okay, so that so that is a difference between a speaker recognition and a speaker verification system. Similarly, if I am interested only in emotion or stress part of the speech, then I can actually, I don't have to process message or language or accent or anything. So I can just focus on extracting the emotion. So those system actually can be emotion recognition system. Okay, so this is one part. So other part is actually you can go for the synthesis systems as well. So what is synthesis system? Just it will work just opposite to the recognition system. So in the recognition, what happened, if I'm going for developing a speech recognition system, the speech input speech will be processed, and a text, the message part will be extracted. But in the case of synthesis system, the opposite happens. For example, if you in Adobe, maybe I can actually take out this, I can show you maybe later. So there is a so you can, in Adobe, you can actually select one of the paragraphs, and if you right click or in one of the options on top, you can find read loud. Okay, this is actually a speech synthesis system. So whatever the text you have selected will be spoken out. Okay, so that is the synthesis system, which is just opposite to the recognition system. And there is a subsidiary application, supplementary application to speech synthesis system, that is actually speech enhancement. For example, in the case of so I have shown you the warehouse environment. So warehouse, a lot of activities are going on. There will be all these activities create noise. Okay, there will be environmental noise, fan noise will be there, AC noise will be there. So all these noise noises will be present. Okay, so our objective, in the case of speech enhancement, the objective will be to what is it, to remove, to clean your speech signal by removing all these external noises. Okay, so that is this one. So there are different types of enhancements are actually possible depending upon the environment or depending upon the context. Okay, and also another important application is actually the voice conversion. Voice conversion is actually like you have a source speaker, you have a target speaker. So is it from the source, the speech of the source speaker can be modified, okay, according to the characteristics of the target speaker. For example, the source speaker is Mohanlal, and the what is it, target speaker is Amitabh Bachchan. You can modify the Mohanlal speech, and you can add Amitabh Bachchan's voice there. So it will be just like Amitabh Bachchan speaking Malayalam, fluent Malayalam. So these are the some of the applications. Okay, so let us just talk about the objectives, overall objective of these applications in the case of recognition. So for example, if I'm interested in speech recognition, so you have
Author of The Danger Trail, Philip Steele, etc.
all right. So I think all of you have listened to this one, right? This audio, right? Did you listen?
But it is not clear. The sound is there, but I don't know
So
what they are saying.
maybe my audio. This is maximum. So
Can you play it once again, sir?
Just a minute. I'll just increase the volume. No.
Author of The Danger Trail, Philip
Now is it
Steele,
okay?
etc.
This is actually a foreign accented speech, basically. So the reason why I showed you played this particular sound is that the objective of speech recognition is actually to extract the message what is being spoken within the audio. So the extracted information is the message there. Okay, but in the case of speaker recognition, okay, it is something like this.
Hello, good to see you.
Okay, so this is me speaking. So here the objective is actually to identify the speaker. Okay, so just identify my name. Okay, the speaker, identify the speaker who is speaking actually within the audio file. Okay, then another one is speaker verification. Speaker verification is just like you're verifying.
My name is Govind. Please open the door for me.
Okay, so I'm just telling my identity, disclosing my identity to the system, and finally the system has to authenticate whether it is me or somebody else. Okay, so that is the purpose. Okay, so these are the application, and in the case of synthesis, what we do is that so you have just opposite to the recognition. So you have the input is text, and you have to synthesize the speech.
A pixel periodically in voiced speech and randomly in invoiced
So
speech.
in the case of in the recent advanced system, actually this kind of glitches will not be there. It will be proper. Okay. Then
Speaker verification is the process of accepting or rejecting the identity claim made by a speaker.
okay, so can you hear this one?
Yes, sir.
Okay, is it clear, right?
It is clear, sir.
So if you notice that one, maybe I'll play once again. It has got a lot of noise there.
Speaker verification is the process of accepting or rejecting the identity claim made by a speaker.
Okay, so in the case of speech enhancement, so we are actually trying to remove this noise, and we are trying to improve the quality of the speech present. Okay.
Speaker verification is the process of accepting or rejecting the identity claim made by a speaker.
When you see the quality is much better than the original speech, though there are some kind of processing distortions are there, but overall quality is much better than the the original one. Okay, and also there is another thing called reverberation. Reverberation is that when you speak something, there will be echo. So echo actually it will destroy the the quality or the intelligibility of the speech. So how to remove it, that is also a part of enhancement. So I'll show you that one.
Many factors influence speech intelligibility.
Okay, so maybe this one.
Many factors influence speech intelligibility.
So there are some problem here.
Many factors influence speech intelligibility. Many factors influence speech intelligibility.
So this is actually the enhancement obtained at various levels. Okay, then you have this one.
System consists of two phases. First, the input text is processed to obtain the sequence of basic speech units. The second phase synthesizes speech from sequence of basic units.
Okay, so what is the specialty in this particular file? In this file, you can see that there are multiple speakers are speaking at the same time. So when you record something, so when two people are actually talking together, if you are actually listening, if as a third person, you will not understand. So what exactly each of them are actually speaking. So if you want to enhance one speaker's voice against the other one, then you can actually make out what that particular speaker is actually telling. Similarly, if you want to suppress one speaker's voice and enhance the other one, and the other person's voice also, you can actually enhance it. So this is one example.
System consists of two phases. First, the input text is processed to obtain the sequence of basic speech units. The second phase synthesizes speech from sequence of basic units.
Of multiple speakers using the knowledge of the implication of speech production. Speech is a multi-speaker environment is collected simultaneously over two or more rationally distributed.
All right. Okay. So I think you can see that in one case, the male speaker is enhanced. Second case, the female speaker is actually enhanced. Similarly, in the case of voice conversion, you have a target speaker.
Not at this particular case, Tom apologized Whitmore.
A source speaker and the target speaker.
Not at this particular case, Tom apologized Whitmore.
So these two files are speaking the same message, same text actually. Only thing is that you have to convert that particular one. One is female, other is male. So you want to convert that one to male, source speaker to male speaker. So what we do?
Not at this particular case, Tom apologized Whitmore.
So some characteristics of the files are actually changed. Okay.
Not at this particular case, Tom
So you
apologized
got
Whitmore.
another quality. Okay, so that is the basic applications of synthesis. Okay. So any doubts so far? Hello.
I think no doubt from the audience, sir.
Okay. So please interrupt me. Otherwise, this is going to be very boring because I'm not very sure. Because I can't even when I share my screen, I can't even see you. Okay. so I can see only my slides. All
Okay.
right. Just okay. So what makes this automatic speech, automatic processing of speech so complicated? So what is it? So it is, first of all, it's an interdisciplinary area. Why it is an interdisciplinary area? Because the speech signal, so it's a signal basically. So you have to apply various signal processing, signal processing, tactics. You should know the signal processing techniques. Then you should know physics. What is the role of physics here? So physics is actually, so basically speech is an acoustic signal, which is produced by the, the vibration of the vocal cords. Okay. So because of the this vibration of the vocal cord, that will act as an excitation, and there will be resonances provided by the vocal tract. Because of that, you are getting the speech. So there are so many physical the principles of physics involved there. So that is actually a part of the speech itself. So based on that, we are actually defining certain parameters. We are measuring certain parameters which are representing these the the physical, the principles of so the phenomenons occurring due to the principles of physics. Okay. Then there is pattern recognition. For example, if you are actually focusing on speech recognition or speaker recognition, then it will be you have to apply techniques to extract certain patterns related to the message or related to the speakers. Okay. And use it for recognition. Okay. Then there is communication and information theory, knowledge. If you want to use speech in the context of communication, for example, if you want to transmit a speech signal from one source to the other source with limited or least limited bandwidth, then you have to go for the communication and information theory. Or if you want to encode your speech signals before transmitting, so that you can provide some security and privacy, all those things you have to apply. You have to take the principles of communication and information theory. Then linguistics, very important. So if you want to develop applications like speech synthesis, speech recognition, so all these applications are language dependent, because the speech recognition system developed for Malayalam will be quite different from speech recognition system developed for Tamil. Why? Because it is dealing with two different languages. So the language related rules related to sound rules, etc., has to be considered. Okay. So that is part of linguistics. Okay. Then computer science. So computer science, the role of the computer science is actually the development of algorithms or search algorithms which will increase the efficiency of the recognition or synthesis. Okay. So all these things are actually quite important. Then psychology. Suppose you are actually working in areas like emotion recognition or any other especially this is the best example, so there are many speech is actually applied for pathology applications, wherein people, even psychologists, used to analyze speech for finding any stress or depression or something like that. Okay. So for that, for those analysis, you need to have knowledge of psychology. Okay. A psychologist can tell that by reading the speech. He can tell that, okay, this person is having severe depression for some days. So what is the level of depression? That doctors will be able to tell, or psychologists will be able to tell. So considering all these the involvement of all these topics makes the particular area so complicated, so challenging. Okay. So in order to develop an application system, we have to consider all these topics. Okay. So basically, so basic idea. So in this particular talk, I'll be focusing more on to the development of speech recognition and speech synthesis. So before that, actually, there is a well-known model. It's called a speaker-listener model. So this is taken from almost all books. This particular model is discussed actually. So you can see that when you speak, okay, so what are the activities in getting involved in starting from your brain, starting from your thought process. It might be generated from your mind, and which will result in the production of speech. Okay, the first thing is actually there will be a thought process which will be generated in your mind, which is again in your brain. Okay, so this is actually the message formulation. From this message formulation, then there will be a language coding happens. Okay, so in which language, for example, if even though I am actually speaking English, okay, basically my thought processes are actually happening in Malayalam. Okay, so that, but this thought process is encoded. There is actually a lot of debate is going on. So how exactly this thought process is generated, in which language, is there any, or is it independent of language? So many things. But as per this particular model, it is thought process is generated in your own mother tongue actually. Then it will be, there will be a coding. Encoding is actually given. A language coding is, for example, if I want to speak in English, language encoding is actually given. Then there will be some kind of neuromuscular actions will be happening. Okay, so which will configure the speech related organs to produce speech. For example, you want to produce certain sounds, so this sound has to be produced, this pitch, this spectral, this spectra. Okay, all these so these are the roles of articulators, as sound, the articulators. So they will be articulators involved, or our tongue, teeth, then your vocal tract, and these vocal cords. Okay, so by the combination of so they should be in a particular configuration in order to produce a particular sound. Similarly, these sequence of sounds will be produced like this. So your positions and your size, your movement of these articulators will happen throughout during the production of speech. So which will enable you to produce speech regularly, as a time varying, in a time varying manner. So that is a story of speech generation. Okay, so what is happening in speech recognition, because you are listening to it. So that is actually your ear. You have upper ear, outer ear, middle ear and inner ear. So this will accept the signals, okay, acoustic signals. So that particular speaker is actually spoken about. Okay, that will be accepted by this um, you know the listener. And the outer ear, including the pinna, will direct this speech sounds to what is that to the through the middle ear, that is the ear canal, and it will reach the inner ear, so which is actually a membrane. So according to the message, according to the speech signal, this membrane will vibrate which is there inside the inner ear. And there will be, when this vibration happens, this is a mechanical vibration. So when mechanical vibration happens, associated some bone system is actually start vibrating. So when it vibrates, it will create some kind of waves in the basilar membrane. Okay, so there are certain neurons associated with that. It will fire those neurons according to the frequencies, various frequencies present in the signal. And these neurons are actually give signal according to the frequency present in the speech to the brain, directly to the brain. So then in the brain, the comprehension happens. That is how our brain is so powerful, that it can actually decode this the neuro, or these electrical signals, or neural, transductions happening. From the received signal, so it will comprehend. It will actually do the opposite to what happened during the speech generation. So if there was a language encoding, so it will be decoded and it will be interpreted by your brain. So these are the speaker listener model which is there in the case of speech communication. So efficient communication between two people. Okay, so the development of all these what is that the systems, or speech recognition system or a speech synthesis system, it is based on this speaker a listener model, which is, for example, if I'm actually interested in development of speech recognition, then I am actually emulating a speech generation, a speaker model. Okay, for example, sorry, speech recognition means listener model. Actually, you are listening. Actually, suppose you are actually interested in developing speech synthesis system, means I'm actually emulating a kind of speech generation model, a speech production model. Okay, so these are the basic models which are there in speech. Okay, so it's the same thing which I told. So I just represented as in the form of a block diagram. All right. So is there any doubt so far? Is there any doubt? Hello?
It's blank, sir.
Blank? No, I just actually stopped the presentation. No, I just basically I can't see your screen actually. Like I want to see the participants. Otherwise, it is just like I don't know. So how can I see the participants?
Click on that participant, sir.
Just I previously I can see these participants, right? So anyway, you are listening to me, right?
Yes, sir. Yes, sir. Yes, sir.
Okay. All right. So maybe you can ask any doubt.
Sure, sir.
How many are there?
Right now, 32 are there, sir.
32. Okay. Anybody has any doubt? Maybe.
Participants, any doubts, queries? We just continue, sir.
Okay. So till what time I can speak?
We have from up to 3:30, 3:15, 3:30, no problem.
Oh, 3:30. Okay. All right. Now you can see my screen, right?
Yes, sir. Production perspective block diagram.
Yeah. So I'm just moving ahead. I'm just moving rather quickly. Basically, if you just look at the speech production, so I'm actually just zooming in. So I discussed about the speaker listener model. So now I'm actually I would like to discuss about this speech production model. Okay, so in the speech production, so you can see a lot of articulators, so a lot of organs which are actually taking part. Okay, so one is actually, so these things are there, oral cavity is there. So the one of the important point is this trachea. So what is the raw material for the speech production? The raw material for the speech production is air. Okay, air. So starting from the air, so what is happening? Why it is a raw material? Because your lungs, so air contained in your lung will be, flowing through the trachea, which is actually the windpipe. Okay, you can see this tube, right? So this tube, so that is actually the trachea, or it is called the windpipe. And at the top of this particular trachea, you have a thin membrane called vocal cords. Okay, so this is called the vocal cords. So there are two things actually: true vocal cords and false vocal cords. Basically, it is another additional membrane, so you don't have to worry too much about it. Actually, certain people, this false vocal cords will be there, certain people it won't be there. Okay, so the thing is that so when the air is flowing through this windpipe, which is actually blocked by this vocal cords, which is a thin membrane. So when the air is exerting certain pressure, these vocal cords will keep on vibrating, open and close, open and close. Okay, so this will periodically will happen, so which will create some shape to the speech signal, not speech signal, the air column. Okay, now it has not generated the speech signal yet. So this I'm just telling the process of the speech generation. So starting from air which is coming from the lungs will be blocked by the vocal cords. So when it start exerting certain pressure, when it is breaches that particular pressure, which is the maximum which can withstand by the vocal cords, it will split open. Then it will create a certain shape to the air column. So that will be again passed through, this air column. The modified air column will be going through these cavities. There are certain cavities here. So one is actually called the pharynx. Pharynx is a cavity. You can see this part. Actually, this is the pharynx cavity. So when some signal or something is actually going through a cavity, there will be cavity resonances. Okay, so that will be added to the air column, which is already modified by the vocal cords vibrations. Then it will be passing through this mouth, and also a part of this will be coming through our nose, through the nasal cavity also. This is the nasal part, so air is coming through the nasal also. This is actually happens when you are actually producing certain nasal sounds like ma, na, etc. And majority of the time, so the signal, the airflow is actually through the oral cavity. Okay, so all these things, all these or what is the organs, we call it as articulators, will take part, or it will contribute in the speech production. Okay, so that is a basic idea. Now, in a nutshell, as a summary of this this one. So there is a mechanical equivalent of a speech production system. So since this particular FDP is organized by mechanical engineering, you can actually relate to. You have a piston here. Okay, so you can actually adjust this particular lung volume, which is air. So which has the air. So when you push this one up, air will be pushed through this particular vocal cords. The vocal cords are actually located like this, so it will start vibrating. So the pressure is released, it will come back to the same position. So like that, so you have certain cavities also, like I said earlier. You have pharynx cavity, mouth cavity, nasal cavity, etc. So when you give these air is passed through this one, so there will be cavity resonance also will be added. So this, in the case of normal vowels and all, nasal cavity will not take part. But if you are actually producing sounds like ma, na, etc., nasal sounds or nasalized consonants, then these cavity will come into picture. Okay, so that is how we get a speech. This is a speech production process. Okay, and you have so this is the basic speech sound. So how the speech is produced. Okay, so you have a microphone. The role of a microphone is actually to convert your acoustic signals to electric signals. So how it is converted? Okay, the one way is actually you can apply the Faraday's law, where if you have a mic, okay, mic which is actually which has magnets, and it has diaphragm kept within the magnetic field. When the diaphragm starts vibrating according to the pressure variations in the acoustic signal, it will induce certain pressure. Okay, that will create some kind of this one variations in the electric voltage that will be given to the wire, and the wire will capture those variations. Okay, so by the when you connect that wire to your computer, which is a digital device, the analog to digital converter of your your computer will convert that one to the corresponding species. But so whatever we are using, the for example this microphone, okay, it does not have magnets there. So it is actually produced, the speech is recorded by using the variable capacitance, which is that is why these headphones became so cheap, because less costly, because of the invention of this variable capacitance. So according to your pressure variations, you can actually the capacitance can be varied. So according to that, you can actually it will introduce certain induce certain variations in the electric voltage that will be recorded. Okay, so these are the certain activities which are having during the acquisition of the species. Got it. So when you are actually talk about this speech production, so this is actually this signal is actually the first modified air column, airflow, actually, which is modified by the vibration of the vocal cords. Okay, then you have this one. So the corresponding speech which is produced, okay, through the so which is recorded through the microphone. The speech signal is something. So compared to the speech signal, this is quite smooth, this air column, because it has this one vibration of the vocal cords. Basically, so it is yes, not going to discuss about this thing. So we have a device called electroglottograph. If you keep kind of sensors across your across the what is it the across your throat, basically exact position is Adam's apple. So the position of the sensor should be across the vocal cord. So there are two vocal membranes for this vocal cord. So one is here, one is here, one is in the right and one is in the left. So if you keep these sensors around here, then so what these sensors will do is that it will vibrate. Okay, when the vocal folds are vibrating, a small current will be passed between the sensors. One is positive polarity, and another is negative electrode, a positive electrode and a negative electrode. So whenever the vocal folds are actually in a closed position, so this is a short circuit. So the current will pass without much impedance. When it is open, the impedance will be higher, so accordingly it will generate a kind of variation. Okay, so that is so this is the example. For example, if I give
Author of The Danger Trail, Philip Steels, etc.
you can see that there are certain variations, the vibrations. You can see that compared to speech, it is not clear. But so it is just like, so when you speak, when you keep our fingers here, this one here, just keep your fingers here. And if you speak, you can feel the vibration, right? So this vibration is actually called a glottal vibration that can be recorded. So for different applications, you can actually use that signal. For example, if you want to accurately locate the pitch of the speech, then you can use this particular signal. So this can be extracted using a device called electroglottograph, and the signal is actually known as electroglottographic signal. Okay, and so when you consider the speech signal, so I'll just speak about the different regions in speech. One is a silence, so this part is actually silence, so I have labeled it. Okay, this is a voiced sound. So sounds which are produced due to the vibration of the vocal. So like I said, to produce a speech sound, there should be vibration of the vocal folds. So in certain, for producing certain sounds, the vibration is not needed. Okay, it will be, there will be turbulent airflow. So sometimes it will kept the vocal cords will be kept open. So when it is open, only the airflow will be there. So that will be a turbulent airflow. So that is actually, so it will be noisy in nature. So that is also a valid sound. So that sound is actually represented by unvoiced sound. So you have silence, voiced, unvoiced sound. So in speech processing, one of the important application, one of the important research area is actually to segregate or classify whether a particular region is silenced, unvoiced, or voiced. So this is actually known as a glottal activity detection, or in the case of speech recognition, so we would be interested in what is the starting point of speech, what is the end point of speech. So maybe I will be interested in cutting up this one, this part, and this one automatically. So that is actually known as speech non-speech detection, which has a lot of applications. Okay, especially in speech recognition, where if the silence region is too much, then if at all the signal has certain noise, your number of frames with more noises, with the noises will be more. So when you try to model it, your model will be modeling the noise more. So in order to avoid that, most of the time we will be applying this voice non-speech or speech non-speech detection for removing the end silences before model. Okay, so these are the applications. So any doubt?
Any questions from the audience?
Yeah.
I think everybody is clear.
Everybody is clear or sleepy because afternoon. Maybe can you just tell me about the participants? Like all are working in mechanical.
No, sir. 50% mechanical. Then the other remaining are computer science and EC.
Okay. All are faculty from Vishwajyoti or?
No, sir. No, sir. Throughout India, we have faculties.
Okay.
25% only Vishwajyoti.
Okay.
But because of today's Hartal, the from Kerala is very less.
But Hartal will not affect online.
They are getting home, sir.
Oh, all right. Yeah. But the college is open, right?
Yes, sir. Yes.
Okay. All right. I'll just maybe I can skip this because I have to wind up into another 20 minutes, right? So I'll just skip up. I'll just discuss about the various sounds, okay? Because I'm just straight away going to the speech recognition. Okay, so let us discuss about these various sounds. Okay, so basically in English, actually, there are sounds like vowels. Okay, so vowels is actually classified into again or categorized into front vowels, mid vowels, and back vowels. All right. These are the classification of the vowels is actually based on where your tongue is positioned. Okay, so if the tongue position is in the front, then it will result in front vowel. For example, you have eve, it, hate, met, etc. Then you have in the so there eve means that e sound. So I is actually that sound. It is represented as a sound e. Okay, that is represented as I. Okay, so e is actually, so when you speak e, your tongue position is actually at the front. Okay, tongue hump is actually the front, that is why it is actually front vowel. So you have mid vowels also, where your the tongue position is at the middle. So for example, father, father. Okay, you can see, you can just observe where your tongue is going, is position. So accordingly, obey, 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 all. Okay, so all. So then also you have back vowels. You have book, book. Okay, boot, boot. Then up. Okay, so there your tongue position is actually at the back side. Okay, and also you have similar kind of combinations of different vowels are actually possible. So those sounds are actually known as diphthongs. Okay, you can see that diphthongs is a combination of by, I, ay is the diphthong. It has a combination of by, and I. So that is actually known as, and also we have down, bait, boy. So all these sounds are combinations of this, and also we have other categories like affricates, sports, judge, church. So the ch, j, so all these sounds are actually known as affricates. Then semi vowels, you have um, L, run, etc. Yara, lava. Okay, so that is these semi vowels. Then consonants are, you can see nasal consonants, ma, na, ng, etc. These are all consonants. Then you have plosives like ball, depth. Okay, again you have voiced and unvoiced plosives. Then you have fricatives, again voiced and unvoiced fricatives. You have wat, voiced, wat, that, zoo. Unvoiced one will be fun, for. All these things are unvoiced. Then thing, then sat, should, shop, etc. So all these are all unvoiced. Then you have whisper sound for certain sounds like he, the h is actually silent there. So that one is actually the whispers. And if you come to the Indian context of sounds, the sounds are basically classified based on, for example, in this particular English sound classification, the English is a phonetic language, because various phones, so the sounds are, the words are constituted of various phones. For example, apple. So it has the basic sound unit like a, p, l. So a is a phone, p is a phone, l is a phone. Okay. So similarly, hello, ha is a phone. So all this chart is actually represents a phone actually. All right. So this. particular English language is a phonetic language, whereas the Indian language is okay. So sometimes for the development of certain systems, we will be modeling the Indian languages as phonetic language. But even though that is the case, certain people are actually, the linguists are telling that the almost all the Indian languages are syllabic languages. For example, we were taught in your schools like that. For example, ka kha ga kha nga ka. Ka is actually, in the case of English, it is k. That sound, that is the sound is important. But in the case of Indian languages, it is ka kha ga kha nga, cha cha ja cha nya, ta tha da tha na. We were taught like that. So this ka is a syllable. So it has got its unvoiced part. The k sound is there, then followed by a vowel, ka, ga. So how do we distinguish between that is the role of a recognition system. So how do we distinguish between these sounds? For example, if I want to distinguish between the ka and kha, then the basic idea is like, ka, the first part, ka part is unvoiced, but unaspirated. Unaspirated means when you speak, your air is not pushed out of your mouth. Okay, ka. You don't feel any kind of pressure there. You can just keep your hand like this, okay, or palm like this against your mouth, then speak ka. Okay, so you don't feel any pressure. But when you actually speak the ka sound, ka, so your air is actually pushed out of this one. Okay, so so that is actually, so that particular sound ka is called again unvoiced but aspirated, because the air is, your aspiration air is actually pushed out of your mouth during the production of that one. Similarly, ga is voiced but ka is unvoiced. Ga is voiced and unaspirated, but ka is voiced and aspirated. And similarly, you have nasal sounds as well. So you have all these nasal. Similarly, the ka kha ga kha nga, all these set is actually produced at the velum. So velum is there, is an organ in our mouth. Actually, if you open your mouth, you can see there is a splitting happens at the end. So that is called velar constriction. That is actually a split. It's a constriction basically. So when the speech is produced at the velar constriction, then it is called so velar sounds. Okay, so ka kha ga kha nga are examples of velar sounds. Palatal sounds is actually cha cha ja cha nya. Okay, palate. So it is actually produced with the help of palate. Then alveolar. So all these are all organs in our mouth. The dental, teeth. Okay, so when you speak, your tongue will touch dental teeth. Then those sounds are actually known as the dental sound. Okay, so then bilabial sounds are there, pa pa ba pa ma. So labial, okay, pa, a rounding of lips will happen. Okay, so these are the categories of Indian sounds. Okay, now let us proceed with the development of, so I'm just skipping all this. I'm just using the development of, I just discuss about the various projects which are happening in India, which is related to where I was actually which I am involved, I was involved in. So these are all kind of old projects. Actually, one is 1D project which happened from 2012 to 2015. Okay, so it is actually a Monday project. This is how it happened. So there is a farmer. It is actually um, developed to help the farmers. Okay, in India, where farmers will be able to speak to this particular through over their mobile phone to know any the price of the commodities. So what it does is actually what it does is when I speak, if I want to know about the price, the daily price of chilies, I'll just speak to this toll-free number. Then I'll tell, okay, so I want to know which. So this call flow management system is there. That is a server. This is the asterisk box. That one is actually call flow. That call flow will be actually managed. So it will through an IVR system. So it will give response back through the speech synthesis system, that which commodity price you want to know. Then the farmer will tell, okay, I want to know about the chilies. So it will recognize and it will, once the keyword is recognized, it will be given to the website. So a search operation will happen there. So it will search out it will search the corresponding price for this chili per kg or per quintal. Okay, that will be returned to the farmer. Okay, so this way it's actually so you can see, if you go through this particular link, you can actually see how it is working. Okay, so that is a basic idea. So that is one of the one project which happened. Then another one is a phonetic engine. Okay, so which has it was running from 2012 to the 2014 or 15, I'm not very sure. So this is actually to recognize the basic sounds in this one by matching the acoustic patterns. Okay, so that is one thing. Okay, then so these are the, so what are the challenges involved in the development of speech recognition system? One is that we have to go for so in the speech recognition, so whatever may be the environment, okay, whatever may be the environment, you should be able to recognize it. So you will be speaking in a noisy environment, you will be speaking with different accents, even though it is Malayalam. So a person from Thrissur comes and speak to the system should be able to recognize his speech. A person from Trivandrum also speaks to the system, then system should be able to recognize the speech. So the system, whatever the system what we are actually developing should incorporate all the, it should be independent of the accents, it should be independent of the what is that noise, it should be independent of any other variabilities such as sensors. So whatever the mobile phones or whatever the headphones or whatever the microphones, whatever we are actually using, your system should be able to recognize the speech. That is a major objective of speech recognition. Okay, so development of okay, so major development stage speech recognition involve the development of a database. Then you have to use proper parameters to represent the speech. Then you have to go for the statistical models to model the basic sound unit. So here this is where we are actually using different machine learning models to understand the statistics of these parameters for each sound units. Okay, so we have started with HMMs, hidden Markov models. Then they are all replaced by the deep learning, networks. Okay, then the recognition of the data. So you have developed as a part of the training, you have developed the statistical models, or the machine learning models, or a deep learning models for each of the sound units. Then what you have to do is that you, using these models, you should be able to recognize. So when you speak to the system, the parameters, whatever the parameters you have used for modeling will be extracted from the data, and the data will be compared with these models, and these models will be able to predict the system. Will be able to predict the sound units. So if you connect various sound units, you'll be able to generate the sentence or word, okay, in which the sound units are present. Okay, that is how the prediction happens. So these are the challenges. Should cover all possible coverage. Sound coverage should be there, it should be large. Okay, you have to use all these close speaking. So I'll just show you a figure. So this is me just taken some time back, actually. So this is a facilitator, so there will be conversational speech will be recorded. Okay, so all these you can see all these. Maybe I can play this. I don't know whether this will be. Oh no. Oh no. I think it is stuck. It is not opening. All right, just so you can. The idea is actually like so I'll be speaking. There is a headphone mounted over my ear. Okay, so that is one sensor. So it will be recorded through this mobile phone. This is through this laptop, through the sound recorder. So in multiple channels, this sound will be recorded and it will be used for the recognition. Okay, and I'll be involved. I'll be engaged in a conversation with this particular fellow, and that conversational speech also will be recorded. For example, when you speak in a news room, a news reader is actually reading a news. So that quality when you is different from when you are actually speak with your friend, when you are involving in a conversation, a dialogue, two-way communication. That time also your way in which you are actually speaking will be different. That is actually conversational mode of speech, and the other one is actually a newsreader quality. So reading quality, read speech, we'll say. Okay, so I think I'm just winding up here. So these are some of the examples. So these are some details of the development databases which are available. Okay, so and these are all some of the dictionaries which will provide. It's called a phonetic dictionary or the lexicon dictionary. You have the words and the corresponding phonemic decomposition. Then you have the parameters because you're going to model these parameters only. You are going to extract these parameters called MFCC features. Then these are the models. So I just put the example of an HMM. So wherein you are going to find the probability of words given the observation. So these are the observations. So in order to find this, you have to first of all find the probability of observation given the word. This is actually the training. So these are the models, statistical models you are going to learn from the parameters. And this is the language model. This will be discarded. Okay, so probability of observation, that is equally likely. So any observation can come at any time. So that can be discarded. So this is the basic phone model, HMM's HMM phone model. Okay, so the prediction is based on maximum likelihood prediction. So you have this models generated as a part of training, M1, M2. This is not M1, this is M1, this is M2, M3. There's a mistake here. So you have the observation, the testing data, you have some observation. So you are going to develop, so you're going to compute this probability of observation given the model. So each model will give you a probability. Whichever is actually maximum will be recognized as the sound model. Okay, so these are the basic algorithms used. Okay, and it is evaluated based on the how many words are correctly classified or predicted compared to the original ground truth labels. Okay, so accordingly, that is the performance metrics of speech recognition. Okay, so these are the available toolkits actually. So this is the most widely used toolkit, Kaldi. So which has all the deep learning modules, all the end-to-end recognition modules, all the latest this one developments in deep learning will be available as a module, and it can be used for this one in Kaldi. Okay, so that is a basic idea. So I'm just stopping here. Is that okay? I think 3:30 already. I think I'm.
Yeah, it is okay.
Okay, yeah. So I'm just so you can ask any doubt. Maybe I can. Well,
audience.
We'll just stop my sharing.
Now it's time for the question and answer. Any queries from the audience?
See, this online is very difficult actually in this aspects because I remember I think 2017 I was again I was invited in Vishajodi where I took continuously for 2 days with hands-on without any problem. But while taking this class for this 1 hour itself, it's very tiring. It's very
Okay, so since
difficult actually.
no other response, we can wind up, sir.
Yeah,
Okay.
we can wind up.
Thank you very much, Dr. Govind.
Thank you.
So,
okay, thank you.
Coming to the end of the session, let me invite Abib Paul for the vote of thanks.
All of good afternoon to each and everyone. So first of all, I would like to extend my thanks to Dr. Govind sir for taking a fruitful and informative section on speech recognition with application to robotics. So thank you, sir. Thank you very much. Next, I would like to extend my thanks to all the participants of this program for attending the program towards the end. Thank you all. And finally, and not the least, I thank all my colleagues for making this event happen. So thank you all, and see you again tomorrow. Thank you.
Thank you, Dr. Govind sir.
Okay, thank you, sir.